So the next topic is arc length. Arc length and volume element. Volume elements. Arc length and volume elements. Arc length and volume elements. From R vector, say, curvilinear coordinate system. We know that in curvilinear coordinates, the position vector depends upon the three coordinates u1, u2, u3. We know that in curvilinear coordinates, the position vector of a particle of an object depends upon the three curvilinear coordinates u1, u2, u3. From this, we have R differential already. If we take the differential of R, what do we get? First, we'll differentiate this with respect to u1. This will be del R by del u1 multiplied by du1 plus del R by del u2 du2 plus del R by del u3 du3. This is similar. This expression is similar to the total differential of a function which depends upon three variables. Total differential of a function f which depends upon three variables x, y, and z. Total differential of a function which depends upon three variables x, y, and z. Let me see if I have the expression here. Okay. The only difference is that here R is a vector. Formula though, the total differential of a function which depends upon many variables to the same formula. Only thing is that here instead of f we have a vector quantity R. And this del R by del u1, we already know what is this equal to. This is equal to h1 times e1. What is this? This is h1, the scale factor corresponding to the u1 coordinate, times the unit vector corresponding to the u1 coordinate. So this is equal to this times du1 plus h2. So this is differentiation with respect to 2. So this will be h2 e2 du2 plus h3 e3 du3. Clear, never. So I can keep the unit vectors at the last. So let us write it h1 du1 e1 plus h2 du2 e2 plus h3 du3 e3. So let's record. Okay. Then the differential of arc length. When a particle moves across a small distance, displacement in the form of an arc length. The differential of arc length ds is determined from the expression from ds square equal to dr vector dot dr vector. Differential arc length can be ds na p. This differential arc length magi expression ds is equal to, is given by this expression. The ds square is equal to dr square dot dr square. Differential arc length ds square. So let us write this dr vector dot dr vector. And what is dr vector? Dr vector is this. So what will we get? We'll get this one expression h1 du1 e1 plus h2 du2 e2 plus h3 du3 e3. Dot product with itself. h1 du1 e1 plus h2 du2 e2 plus h3 du3 e3 dot of this and this. So I have three terms here. Say that I have three terms. 1, 2, 3. I have three terms. 1, 2, 3. So dot product already. I'll get 9 terms. Siga mu dot over plus siga mu dot over plus siga mu dot over. So 3 terms. Next again mu siga mu dot over plus siga mu dot over plus siga mu dot over. I told them 6 terms. We will get another 3 terms, and in total we have 9 terms. 9 terms from them. But if the coordinate system, if the curvilinear coordinate system is orthogonal, we'll be discussing only those coordinate systems which are orthogonal. I don't know, for orthogonal systems. For orthogonal systems, today you can see orthogonal system that the unit vectors are mutually perpendicular to each other. So E1 ziga E2 ziga dot of 0 for orthogonal systems, what do we have? We have E1 dot E2 equal to 0, comma E2 dot E3 equal to 0, comma E3 dot E1 equal to 0. For orthogonal terms, these are all 0. Adudi sidagidi 9 terms le madudagi, many of those terms will become 0. So what remains is only 3 terms. For orthogonal systems, therefore ds square equal to siga multiply to h1 square du1 square e1 dot e1 the unit vector dot the answer is 1. So 1. So plus siga dot h1 h2 du1 du2 e1 dot e2 0
0.
terms siga mung kanda e1 dot e3 0 next time sigi e2 sigi e1 ziga dot tobuda 0 next time da siga manam magi mapasana budurang taroneba. So this will be h2 square du2 square plus h3 square plus
du3 square.
So for an orthogonal curvilinear coordinate system, ds square is given by this expression.
Plus
ds karikawi the plus sorry, this should be multiplication. This should be multiplication. This is not addition, this is multiplication. ds is differential arc length. ds is called differential arc length. So ds square equal to h1 square du1 square, h2 square du2 square, h3 square du3 square. For orthogonal curvilinear coordinate system. For non-orthogonal curvilinear coordinate system, orthogonal ordergadi dot particularly 9 terms pangani. Next up. Let us take the differential of volume element. Aduna sidayang asi along a curve ko sagi curve home do sinen kana zero. This is U1 curve. And this is the unit vector. So let us call it H1, U1, E1. H2, U2, E2. This is U2. Sorry, this is U3. So this is H3, U3, E3. And this is U2. So U2 is na. This is U2. So this is H2, U2, E2. So along a curve, along a U1 curve. So along this U1 curve, U2 ga U3 ga constant or any. U2 and U3 are constants. So that dr is equal to H1 du1 E1. The position vector is given by H1 du1 E1, H2 du2 E2, H3 du3 E3. So if the particle is confined to move only along the U1 axis, U1 curves the particles is a target say du2 0 chale, du3 0 chale, du1 0 chatre. Because the particle is moving along U1, so its U1 position is changing, so du1 is not 0. Here is what we get here. dr equal to H1 du1 E1. Ate 0 chatre. Stop. Then the differential of the arc length ds1. So the differential of arc length along any arbitrary path to the term but differential along, but when the object is moving only along the U1 axis, we call it ds1. ds1 causal. ds1. Arc length along U1 at P. This is the point P. So point P. I repeat, then the differential of the arc length ds1 along U1 at P is ds square equal to dr dot dr natra. Dr dot drd this is equal to h1 square du1 square. So square root of the arc length it's always a positive quantity, so ds equal to h1 du1. So the differential arc length. So the differential of the arc length ds1 along u1 at p is given by this expression, which is ds1 equal to h1 du1. Similarly, the differential arc length along u2 and u3 at p are ds2 equal to h2 u2 and
ds3
equal to h3 d3, which is represented by this. So the differential arc length along this direction is h1 u1 e1. This is h2 u2 e2. This is h3 u3 e3. Using this three, I can construct a volume element. Using this three, I can construct a volume element. Wow. So using these three, I can construct a volume element like this. H1 U1 sangi, amana H2 U2 sangi, amana H3 U3 sangi. This volume element. So the volume element, sigi sigi axis sigi axis kam sangi, amana H1 Du1 sangi along, and this is along E1. Amana H2 Du2 sangi, this is along E2. Amana H3 Du3 sangi, this is along U3. The volume element for an orthogonal curvilinear coordinate system is given by dv. This is equal to when a vector algebra class 12 ki vector algebra that taritamgre, I have a volume. I want the volume volume element. I have a three-dimensional object. The magi corresponding edges ahum h ahum ka h ahum ki vector v1 v2 v3 na h already. What is the volume of that three-dimensional object? This is the scalar triple product quadrant. The scalar triple product or the box product of the three vectors. Aduna thangnaba h ahum ji vector oina piram targadi sigi three-dimensional figure sigi volume hot ke haidi sigi vector ahum sigi kari dogani box product natraga scalar triple product. And so sigi han vectors ne kaino h1 u1 e1 ani subujne kaino h2 u2 e3 ahum subujne kaino h3 u3 e3. So this is given by h1 du1 e1 h1 du1 e1 dot h2 du2 e2 cross h3 du3 e3. By then it's determinant, because this scalar triple product by determinant, sorry, modulus have a call. This scalar triple product will give you a scalar quantity, and this quantity can be either positive or negative. But since volume is a positive quantity, you should take the modulus. So the vector nataba quantity do mapan thamo. So h1 du1 I can take outside. h1 h1 log to, h2 log to, h3 log to, du1 log to, du1 du2 du3, and atay thamo e1 dot e cross e3. Atra atay di h1, these are simply numbers, these are not vectors. Vector nataba scalar quantity ke mapan thamo vector thamo. This is like I cap, j cap, k cap. So this is a volume. This is a three-dimensional object formed by E1, E2, E3. Mutually perpendicular to unit na amam sange. So what is the volume of the cuboid? So the cuboid, what is the volume of a cube with the h length 1? H length 1. Cube to volume kai orani, so 1 so this is 1. This is 1. Cube high karigino moi ahum jeloi sangmane 1 1 1 loi sangi. Adudagi moi ahum je mutually perpendicular oine. That means these three they form a cube of the one diagonal. So what is dv equal to? So dv equal to h1 h2 h3 du1 du2 du3. So this is called the volume element in curvilinear coordinates. I don't know whether we'll have time to solve one example or not. So let me stop recording, or we can try to solve one example. We have only 3 minutes remaining. we have only 3 minutes remaining. So I don't know if we can complete this or not. So the ds square is hot cylindrical coordinates. For cylindrical coordinates, let us calculate ds square. ds square is cylindrical coordinates hot ds square is conditioner hot ds square equal to dr dot dr sinner hot cylindrical coordinates of dr gi so in cylindrical coordinates, let me give you the hint. You can try it at home. ds square ds square equal to dr vector dot dr vector. Now dr vector is and this can be written as when dx square plus dy square plus dz square in rectangular coordinates. In rectangular coordinates, this is dx square plus dy square plus dz square. And if you want to write it in terms of cylindrical coordinates, x equal to rho cos phi, y equal to rho sin phi, z equal to z. So you can calculate dx. Differential holo. This is minus rho cos phi derivative t minus rho sin phi d phi. Plus cos phi 0. So dy rho cos phi d phi plus sin phi d0. dz dz so you substitute these 3 values in these 3 expressions and you obtain ds square in terms of these 3 expressions, and then you group together terms containing phi, rho and z, and the final answer that you should get should be equal to d rho square plus rho square d phi square plus dz square. So say you try it out. Recording just stopped out again.